Hello everyone and welcome to my class. In this video, we're going to talk about patterns and isometries. To start off, let's first define isometry. Isometry is also another term for congruent, which indicates a figure where its shapes, sizes, angles, and measurements are preserved. This is highly connected to patterns since a pattern has an isometry of the plane that preserves its figure. Or should I say pattern? I'm sorry. From this image, you can observe these two identical figures that are proportionate to one another as they are placed in two different places or what you call points. These figures aren't just placed anywhere where this figure will have another figure over here or there, but they are actually placed with a fixed distance and a fixed placement. And when I mean placement, where each of these shapes didn't overlap with one another like this one and the other shapes, which created a pattern. This is possible because of isometric transformation, where one point of the figure is shifted to another point as the figure retains its shape and size. There are five main types of transformation, which is translation, rotation, reflection, glide reflection, and dilation. The reason why dilation is not part of it because it is, although it is a transformation, it is not part of the isometric transformation category, but it will be explained later. So first, translation. This indicates its initial point of the figure to its sliding through its final point on any direction. In this case, there's no fixed point, so its final its final point figure can actually be placed anywhere. Aside from this one, it can also be placed over here, but the distance is fixed. As for the rotation transformation, this indicates about a turn where the requirement is the center and the angle. In this case, we can observe how this in its initial position it is rotate to the left, and the image is also proportionate to the angle to 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 the center where it's also changed, where although the image is rotated as well, its shape and size has retained. As for the reflection, the figure simply flips over the line, where just like how a mirror works. And as for the glide reflection, this is a combination of translation and reflection. In this case, how this happens is that it first performed the translation transformation where it glides through over in this point, and then after that it actually performed its reflection, which will actually be reflected to the other side of the mirror line. So in this case, this whole figure is actually an example of a glide reflection. So next, why don't we set up some examples where you'll have to identify any of this perform the right transformation. So in this case, is this an translations isometric where, well, we can see that in this point, let's say its initial point going to this direction, we can tell that the figure retained while the points have been shifted. So this is a yes, this is a translation isometric. As for the rotation isometric, we can observe this image is being rotated to the right from this one, from this initial image. So yes, it is also a rotation isometric. As for the reflection isometric, obviously there's a mirror line in between them where where its initial image is being reversed. So yes, this also reflection isometric. There is also another type of transformation where the shape and size of a figure are distorted. This means that after transformation, the figure does not preserve its image, which I stated before, the shape, size, angles, and measurements. Here is an example of dilation, told, which is one of the basic transformations in this topic, where in dilation, the figure is either enlarged or reduced. Now, here is an example where we apply transformations in this coordinate grid, where we will use a mathematical equation to perform transformations. So it says determine the coordinates if the of the image, plot the image and determine if it is an isometric transformation or not. So we had this first, it's pre-image points. By the way, this is actually what you call the initial points where before its transformation. And we have to follow based on the coordinate rule, we have to transform into this equation. So -1 will become negative. So x will become -1 and y will become -1. X will retain while y will become -4. And as for c, 4 will retain and 1 will become -1. Now, the next step would be to insert these points into this coordinate plane, which we will get this figure. And as you can see, and as you observe from this image, we can tell that this is actually a reflection transformation. And is it an isometry? Yes. So that's how it is performed in the coordinate rule. And as you can see in the coordinate rule, this isn't just simply about inputs or outputs, but it's more like transforming the image or shape. And in this following, these are the following formulas where you will get the reflection, dilation, and translation used, used so that you can actually see how they'll change in the coordinate plane. This is just the basic um, formulas and there are many more to it. But as of now, this is all what you need to know.